session we will discuss about the pressure distribution over a symmetrical aerofoil. So the thing what I am having in my hand is a symmetrical aerofoil. So this is the aerofoil. So this part, this is the front part of the aerofoil, we call this as a leading edge. The rear end of the aerofoil we call it as a trailing edge. So that means that this is really leading edge and this is the trailing edge. If you draw a line connecting the leading edge to trailing edge, that will give us the chord line of an aerofoil. Okay. So in the chord line, if you split the upper surface and the bottom surface of this particular aerofoil, means if the after splitting, if the thing is symmetrical, means that aerofoil we call it as a symmetrical aerofoil. Upon splitting the upper surface and the lower surface, if the thing is asymmetrical, means then we call that particular type of aerofoil as a cambered aerofoil. To be tested in the wind tunnel. So this is a symmetrical aerofoil. If you see here at the surface of the aerofoil, means here you can able to see the holes. So here the holes, this is the location where we are going to test the pressure. So here the holes were named like this. So this is the hole number 1. Here you can see the naming. Okay. So this is the hole number 2. Here you can see the numbers. Okay. So similarly, so this particular aerofoil is also having rakes. So these rakes are connected with these holes. So these rakes, again it is connected to the plastic tubes here and it is numbered. Okay. So say for example here the number is 1, means the same number is connected here. Okay. So this will be connected to the multi-bank manometer after fixing this aerofoil section into the test section. Now you can able to see the symmetrical aerofoil kept inside the test section. So this symmetrical aerofoil is kept at 0 degree angle of attack with reference to this protractor. So at the bottom of the symmetrical aerofoil, here you can able to see the plastic tubes. These plastic tubes are connected to the multi-tube manometer here. So the number 1 point, pressure point of the model is connected to the number 1 tube of this manometer. Similarly, number 2 pressure point of the model is connected to the second tube of this multi-tube manometer. Similarly, all the tubes are connected to the multi-tube manometer. Now we are ready to conduct the experiment. So as we all know that we have fixed the model inside the test section. So how to perform this pressure distribution over a symmetrical aerofoil means, so we need to keep the test section velocity as constant, and then we will be changing at angle of attack of the model, that is from initially it is 0 degree angle of attack, means the next we will be changing with 5 degree angle of attack, 10 degree angle of attack, 20 degree angle of attack, like this we will be changing, and then we will be conducting. To start the wind tunnel, so we are here into the controls panel. So here is a green button. If you press this green color button, this wind tunnel blower unit will get started. So once the power unit is switched on, so here the blower unit will, centrifugal blower unit will keeps on rotating. So by adjusting the hand wheel by up and down, we can able to vary the test section velocity inside this test section. After switching on the blower unit, so the wind tunnel starts functioning. So here, this is the place where our pitot probe is located. So using the pitot probe, we can able to measure the test section velocity. So the del H value, that means that the manometric head values can be measured using this U-tube manometer. Then to measure the pressure values at various locations of the aerofoil, we need to take the readings from the multi-tube manometer here. So here this water level will be changing based on the pressure distributions what is occurring in the model surface.